So before starting nyquist plot, I will request you to see the polar plot videos because this is related to that. Actually, nyquist plot is extension version of polar plot. So in polar plot, uh, rather than the polar plot, here we can see that it gives nyquist plot gives gain margin, phase margin along with the number of roots in the right side of the S-plane. For this reason, we prefer nyquist plot. So before that, we have to understand some concepts, that is enclosed, not enclosed, and encircled. If we are drawing any polar plot and our reference point minus 1 j0 if is under this, actually this means between the polar plot, then this is enclosed. If that is outside of that polar plot, then it is not enclosed. And if somehow the gain is constant and the phase is changing its way, okay, then and in between that the reference point minus 1 j0 lies, then it is called encircled. So that is concept that will help you after some time, that concepts. Now we have to build up another concept. Let's take, we have taken gs is this and our hs is unit hs. So the open loop transfer function will look like this, and the characteristics equation 1 plus gshs, it will look like this. And after that our closed loop transfer function, that will be gs by 1 plus gshs, that will also look like this. Now at first compare 2 and 3. Secondly, the stability condition of nyquist plot. The nyquist plot stability condition states that all the closed loop poles are at the left side of the S plane. Closed loop poles, all the closed loop poles, so closed loop poles are left side of the S plane. So in the right side of in the right side, there must not be any closed loop poles, no closed loop poles. And closed loop poles is equals to characteristics equation 0. So there will be no 0 on the right hand side. That means 0 equals to 0 in the right hand side, RH side. Okay, so for that one equation is there, n equals to p minus z, where n is the number of encirclement of the point above 1 minus j0. What I have told, encirclement of point above minus 1 j0. Okay, that is n, encirclement. And then p is the characteristics equation poles or open loop poles in the right hand side. Okay, characteristics equation poles in the right hand side. And what is z? Z is the characteristics equation zeros at the right hand side. So for stability at the right hand side, zeros will be 0. That means z will be 0 for stability. Okay, our second point is nyquist contour. Nyquist contour for we have taken one gshs, that is this, and the process is like that. This will be positive imaginary axis, this will be negative imaginary axis. So at first you have to draw the positive imaginary axis. So you have drawn positive imaginary axis. After that draw a semicircle of radius infinity in clockwise on the RH side. So on the RH side one semicircle we have drawn. Now what is said, that draw negative imaginary axis. Negative imaginary axis is this, and that is the mirror image of this. So this is going this way, this way, and after that this. Now what is happening here, map origin without touching it. So we can see that in origin there is one pole. Okay, so the origin there is one pole, so we have to draw a small semicircle here. Okay, small semicircle, because if this pole is on the right hand side of his plane, then the system becomes automatically unstable. So we have taken these radiuses are most approximately equals to 0, and this radius will be infinite radius. Okay, so this is the contour technique. For nyquist plot, what you have to do, nyquist plot we are just have simple 4 steps. So arbitrarily we are taking an example. Let's take k by s 1 plus st. Let's check. So we can see here this is type 1 system. Okay, it will start from here, and type 1 second order, that means order 1 order 2, so it will start from here and it will end at here. Okay, now the polar plot is done. Now what is telling here, we have to map to origin. Okay, so this is map to origin. At origin we have mapped this. Now we have to draw the mirror image of this. So the mirror image will just look like opposite of this, and this will be the mirror image. Okay, the direction is given. After that, a semicircle. So the semicircle from endpoint to clockwise direction. Now one more thing, for type 1 system the semicircle will be 1, and for type 2 system the semicircle will be 2 times, that means 2 semicircle will be there, or for type 3 there will be 3 semicircles. I will explain it sometimes later. And one more thing, we have to check the stability, whether it is stable or not. For checking the stability we are taking one point, minus 1 j0 arbitrary point, that was arbitrarily taking at this side. So from this minus 1 j0 point, if we draw any line, is it cutting any of the semicircle point? No. So this is not encircled. So as it is not encircled, so our n is becoming 0. And the poles, so in here you can see one pole it has at origin, one pole, and another pole is on the left hand side. So in the right hand side there is no pole, so pole at right hand side is 0. So zeros at right hand side will be 0 minus 0, that is p minus n. So that is becoming 0. The system is stable system. Now we take the second example. Second example is GSHS equals to K by S1 plus ST1 1 plus ST2. Okay, now for that our system is type 1 and the order is 3. Okay, order 1, order 2, order 3. So type 1 order 3, type 1 order 3. First, second point, draw the origin, that means map the origin. After that, what is happening, we are making the mirror image of this. So the mirror image will look like this. Okay, okay, right. After that, what we have to do, now draw the semicircle. Here we can see that the system is of type 1. So one semicircle will start from here and it will end at here. Okay, this is done. Now one thing we have to see, that if now we are considering that minus 1 j0 point, considering just 0 point is enclosing this. So if minus 1 j0 point is here, now if we draw any line from here, the line will cut 2 encirclement. So here the n value is 2, and the poles, if n value is 2, and now we'll see the poles. Now here you can see, the poles are on the left hand side, no poles in on the right hand side. So poles will become 0 on the right hand side. So zeros of in the right hand side will become p minus n, that will be 0 minus. Okay, one more thing, that n will not be 2, that n will be minus 2. Okay, because this is clockwise. Okay, clockwise, for that it will be minus 2, so minus 2, that will become plus 2. So the system is unstable as it is not 0. Okay, now if the point, this imaginary point was here, minus 1 j0, our reference point, if it was here, then there was no encirclement, so our n will become 0, then p is already 0 and z is becoming 0, then the system was becoming stable. Okay, now our taking third example, that is GSHS equals to A by S square 1 plus ST. Okay, now if we take this is a second order, oh sorry, type 3 third order system. Type 3 third order system. So type 1, type 0, type 1, type 2, sorry, this is a type 2 third order system. So type 0, type 1, type 2. Okay, so type 2 third order system, that is order 1, order 2, order 3. So the system will look like this, polar plot, and we will map at origin. After that we will draw the mirror image of this, the mirror image approximate. So the mirror image is complete. Now what we have to do, we have to draw the semicircle. From our ending point we are drawing the semicircle. The first semicircle ends at here. Now this is type 2 system, so there will be two semicircles. So again one semicircle will enclose here. Okay, this will be the nyquist plot. Now in this nyquist plot, -1 J0, wherever it is, it will definitely cut through 2 insert limit. So here n value is -2 always, and poles are zeros as usual, because in the right hand side there is no pole, every pole is on left hand side. So right hand side zeros will be 0 minus -2, that will be 2. The system is unstable.